Hi, it's Dr. Bear, and in this video, we're going to be talking about the foundations of the supply curve. Right, that is the neoclassical theory of production. Okay, so production. All right, now most of this discussion, we're going to be talking about the production of certain things. Right, this is kind of like the implicit, bias of the theory. Uh, that is, we mostly are going to be talking about the production of physical items, right? So, physical goods. All right, economics is kind of famous for having its focus on widgets and things like this. So, in order to do this, again, we have to just keep in mind neoclassical economics, microeconomics, is a highly mathematical type of field, right? So we have defined the production function. Okay, let me just refresh your memory. The production function is a mathematical formula that relates our output, that's Q, okay? So Q is the output, and think of this as the number of items of finished goods, right? Whatever the finished good is, that's the number of items, okay? So however it's sold, right? The number of pounds or the number of goods, whatever it is. Okay, and we're saying that output is a mathematical function of the inputs. All right, and to keep things simple, we're just using two inputs. Okay, we use labor, L, and capital. All right, so our inputs, output is a function of our inputs. Okay, so remember L, the number of hours of labor units, and K is the number of units of capital. Right, your textbook sometimes talks about, when they introduce this section, they talk about different kinds of inputs that you might use, including among them technology and entrepreneurship and things like this. That doesn't make a whole lot of sense to me because what we're doing here is we are reducing this into these have to have quantitative units, right? So you can see how we can add one unit of labor, we can add one unit of capital. Actually, there are some problems with this, which we'll discuss later. But clearly, we can add one unit of labor. That's meaningful, right? But I don't know. Maybe somebody could explain to me how you add one unit of technology, right? What the hell is the unit of technology? That doesn't make any sense, right? That technology doesn't have units like that, right? Technology is essentially knowledge. There are no natural units of it, right? And the same for entrepreneurship, right? Like if we're going to use entrepreneurship as one of our resources here or our inputs, then we should be able to know, like, well, what happens if you add one more unit of entrepreneurship? And that is meaningless. That's the problem, right? So we're going to abstract from all these other things, right? Technology, entrepreneurship, whatever the hell. We're just going to stick with labor and capital, okay? That's that traditional two inputs. All right, so just to keep things simple for ourselves. All right, now we're going to make one simplifying assumption about productive units. Okay, those units, we're going to call them firms. Okay, so producers, sellers, firms. We're going to use these terms interchangeably in this discussion. All right, that's the one who produces. Okay, and we're going to make an assumption about all these firms. They kind of like a firm nature, like we had human nature. Human beings maximize utility subject to their constraints. Now here we have firm nature, okay? So here's what all firms have in common, right? All firms maximize profit, right? That is our fundamental assumption about what it means to be a firm, okay? They maximize profit. And so in order to understand this, we need to go into a little bit more detail and define a couple more terms. All right, so first of all, let's just define profit. We use this symbol, okay, the Greek symbol pi. All right, profit is pi. And we will go on to define that pi as the difference between total revenue and total cost. All right, so total revenue, we'll call that TR, and total cost, we'll call that TC. Okay, so we've got to go on then now and define these things. Okay, so we can define total revenue as the price times the quantity that the firm supplies. Okay, so quantity superscript S, quantity supplied. Most of the time I'm just going to put Q, right? But I want to connect this to, remember we talked about the foundations of the supply curve. Okay, we talked about quantity supplied earlier. All right, so this is where this comes from. All right, the price times the quantity supplied, that's the total revenue of the firm. Now total cost, we need to break that down a little bit more. Okay, we have said that there are two inputs. Okay, there's labor and there's capital. And so the total cost is going to be the cost of these inputs, right? That is the number of units that you use times the price of each one. Okay, so let's get into this a little bit more. Okay, let's say the wage, okay, the little w, that's the wage, that is the number of dollars per hour, right? So in other words, the wage represents the price of labor per unit, right? The unit price of labor, okay? And then P subscript K, like this is the price of capital, okay? So we are talking about using units of capital. Well, each unit has a price, okay? So the price of labor and the price of capital, all right? And remember, we are thinking about capital here as physical capital, okay? Physical, the tools, equipment, machinery, etc., which go to producing other things, okay? Which produce finished goods or output, okay? So we've got the prices of each one of these things, and then we have the amount of each one of these things, okay? So the total cost then is going to be the price per unit of labor, that's a little w, times the number of units of labor plus the price per unit of capital, PK, times the number of units of capital. Okay, so again, the first term here represents the cost of the labor, and the second term represents the cost of the capital. Okay, so we've got total cost. We got defined total revenue and total cost, and again, profit is the difference between those two. Okay, so now firms are also very interested in their total cost relative to how many units of output they produce. This is called average cost. Okay, so average cost, also known just colloquially as the cost per unit. Okay, cost per unit, and it's just often abbreviated AC, or sometimes it's abbreviated as ATC, the average total cost. Okay, so so different texts are different on this, right? All right, so the average cost is equal to the total cost, TC, divided by the total output, TC over Q. Okay, and we can expand that into W times L plus PK times K divided by Q, like so. All right, average cost. Firms care a lot about that, right? Their average cost, because on average, the profit is the price that they receive minus the average cost. Okay, and this is the profit per unit. Okay, so profit per unit is equal to price minus average cost. All right, and profit per unit is pi divided by Q. Okay, so very easy way for us to see, is the firm profitable on average, right? What's the price minus the average cost? And this is one reason why firms are so interested in the average cost. Okay, so let's get into what does it mean to say that firms maximize profit. Okay, so here's our headline: firms max pi. All right. Now you can see how similar that is to our earlier formulation when we were talking about individuals. Individuals max U, right, subject to the constraints. Firms max pi, also subject to the constraints. There's certain things that they can't control. We'll get into that more later on. Okay, for now I just want to talk about what does it mean to maximize profit. Okay, so there's a couple of related meanings to this. Okay, the first is that is relative to the total profit. Okay, the total profit, and that we've already defined, right? The total dollar figure. Okay, so if a firm has choices, right, they can either choose profit 1, which is equal to $5,000, or they can choose profit 2, which is equal to $5,001. They will choose profit 2, right? It's $1 greater, okay? And so to choose profit 1, I mean, assuming that this is equal risk and everything else, right? All other things being equal, ceteris paribus, they will choose the larger total amount of profit, okay? So, however, what this also implies is something about the profit rate, okay? So this is a very important concept. We have to define this, okay? The profit rate is, we'll call that little r, right? The profit rate is defined as the total profit, pi, divided by the total cost, TC, right? Now there's an alternate formulation that we might like to use. It's a little bit more helpful in some cases, right? If we expand this a little bit, we say, okay, we've got the profit is the total revenue minus the total cost, and we're dividing that by the total cost, right? And we see that we can separate this out, right? Because we got TR minus TC over TC, so we can go like this: TR over TC minus TC over TC. Now this second term is 1, right? Anything over itself is 1, okay? So we've got TR over TC minus 1. Now here's the thing, okay? This TR, total revenue, is equal to price times quantity, and we're dividing that by total cost, okay? So that's our, and then subtracting 1, okay? Now, but look at this right here, right? This part of this term, okay, TC over Q, this is equal to average cost, but the inverse of it, right? 1 over average cost. Okay, so this gives us our alternate formulation, okay? Instead of this, we can go price over average cost minus 1. Okay, so these are our different ways to formulate the profit rate. Okay, we can say it's equal to total profit over total cost, or alternatively, price over average cost minus 1, right? The alternative formulation might be convenient at certain times, or that's the traditional formulation might be more convenient. For our purposes, we want to understand why is this important, right? Well, think of the profit rate as the amount of profit that you get per dollar of total cost. And obviously that's very, very important, right? So, and this is implied, like when we say firms maximize profit, what we mean also by this, not only the total amount, but they seek the highest profit rate that they can find, okay? So other things being equal, firms seek the highest profit rate that's available, all right? And just to show you that this is the case, right? Let's imagine we have two situations, okay, that have the same dollar amount of profit, okay, $5,000 in both cases, okay. So profit 1, $5,000, profit 2, also $5,000, okay. But here's the thing, okay, the total cost for the first one is, let's say, $10,000, and the total cost for the second one is, let's say, $20,000. Right? So even though we have the same dollar amount of the profit, we're going to end up with very different profit rates, right? The profit rate in the first case, we're going to take the total profit and divide by the total cost. So we're going to get 5,000 over 10,000. Okay, we're going to get 0.5 or 50%. And in the second case, we're going to take that 5,000 divide it now by 20,000, and we're going to get a profit rate of 0.25. Okay, and so the firm is going to, right, assuming that these are both equally risky and whatever else, right, all other things being equal, the firm is going to choose the one that has the higher profit rate, right? Because per dollar of total cost, that matters, right? Like, we could conceive of this as risk, right? If you put more money out there, there's always a risk that maybe that won't all come back or whatever, right? Anything could go wrong, right? So that's higher risk, other things being equal. You would prefer to have more money per dollar, right? The more profit per dollar, okay? So saying firms maximize profit implies both of these things, okay? It implies total profit, and it also implies highest profit rate, okay? The third thing that's implied has to do with the turnover time, okay? Is that firms want the shortest possible turnover time. Okay, what this refers to is how long does it take to complete the production process and realize the profits. Okay, this is what it means. Time to realize the profits. Okay, so let's say again, let's imagine we got two situations that involve the exact same dollar amount of profit. Okay, so profit one, again, let's say it's $5,000. Profit two, also $5,000. And let's say it's the exact same profit rate as well. Okay, so profit rate in both cases, 0.1. All right. However, the time that it takes to do one of these is a lot less than the other. Okay, so let's say that the turnover time in the first case is 1 year, versus the turnover time in the second case is just 3 months. Okay, so do you see why this would be? The firm is going to choose the shorter one, right? They would, even though they're the same profit rate and the same dollar amount of the profit. If we say, well, how much benefit would you receive from this in 1 year? Well, this one you could do 4 times in 1 year, right? So you'd have 4 times as much profit at the end of it, right? This one you could only do once in 1 year. And so there's a big difference between these two, right? And this is all implied when we say firms maximize profit. Okay, so the next step here is to understand the production function in terms of its rate of change. All right, so we're looking at, in other words, the dynamics of the production function. The dynamics of the production function. So what do we mean by that? What we mean is, well, how do the variables affect the quantity? Okay, so, and just to keep things simple for ourselves, what we want to know is, what if we increase our input by just 1 unit? Okay, 1 unit of labor, 1 unit of capital, and holding all else constant. Okay. This is a mathematical technique. We can do this using calculus. Okay, so calculus does this by means of the partial derivative. All right. Now, since this is economics, we're going to proceed not by using calculus, but by using an example. Okay, we're going to try to understand this in terms of economic phenomena. All right, and the way that we do this is by looking at the concept of fixed cost and variable cost. All right, so we imagine that, look, there's lots of things in this world that are fixed under some time period. All right, so let me give a couple of examples of this. Right, let's imagine that in order to have a firm, you have certain things that you have to kind of commit to, right? So what are these things? Well, you might have to buy a series of raw materials, right? You might have to sign a lease of some kind, right? Very common. You might have to make, in other words, a set of commitments. Okay, that's what these are. These are commitments, and a lot of them are financial commitments, right? This is what a lease is. You are going to have to pay that regardless of what else you do That's the only way you get access to space in order to work, right? So this gives rise to fixed costs. These commitments cannot be changed during some period of time, okay, whatever it is, right? Let's say that in order to get a good deal on raw materials, maybe you need to buy a year's worth of raw materials, right? In order to be competitive or whatever, right? You have to sign a year-long lease, okay? Those are commitments. That gives rise to fixed costs, okay? So if something can't be changed during some time period, we have fixed costs, okay? And the time period during which it can't be changed, we will call that the short run, okay? Now we're going to define this in a kind of a circular fashion, right? Because the definition of short run means that period of time in which there are fixed costs, okay? And we've defined it in such a circular way because, we can't really say exactly what that is, right? It's going to depend on, we're trying to do a theory which is going to be general enough to apply to, lots of different situations. And the problem, of course, is that every kind of production is a little bit different or a lot different, right? So what is fixed in one industry might not be fixed in another, Anyway, whatever that period of time is, okay, in the situation that we're dealing with, maybe it's 1 year, maybe it's 3 months or whatever, that the short run is that period of time in which there are fixed costs, okay? Now, that gives rise to the topic of, well, what is the long run then? Well, look, in the long run is after that period of time has elapsed, like, look, if there's some period of time where you make commitments, well, what about after that, Okay, yeah, you had to sign a lease, but that's not forever, right? That's for a year or for whatever it is, right? So there are no fixed costs in the long run, right? It's that period of time which is beyond the short run, all right? So all is variable, okay? All can be changed. However, we're going to use this distinction quite a bit, okay, between fixed cost and variable cost, so much so that we call fixed cost FC and variable cost VC, okay? And variable cost just simply means it can't be changed. All right, so we've got things that can't be changed, fixed costs, and things that can be changed, fixed and variable costs. Now, in practice, what we almost always do is we almost always say, all right, the fixed cost, it could be anything, right? But remember, just to keep it simple, we've said that there's two inputs, right, in our production function. So Q equals F of L, comma, K, right? And in terms of the math of this, just to take an example, okay, this is a general version of a function, right? To make it more specific, we might take a classic form, okay? We might say, for example, the output Q is a function of labor to the 1/3 power times capital to the 2/3 power, okay? So this is a famous kind of production function, the Cobb-Douglas production function, okay? So it's just an example, all right? Now, to continue with our story, though, right, this is the math part. Economics forces us to kind of go back and forth between the math and the story, right? So what I was telling you before, that's the story part, right? There's fixed costs and variable costs because of these commitments that can't be changed in the short run, okay? So what that means mathematically is there's something here that is fixed, right? Now, like I said, in practice, our example, every textbook I've ever seen uses capital as the thing that's fixed, okay? So when we do something as being fixed, we put a little bar over it, right? So meaning fixed in the short run, all right? Fixed in the short run. So quantity as a function of labor and capital is fixed in the short run, okay? And, like perhaps for the reasons I mentioned, okay, we got to buy a year's worth of raw materials or whatever, we got to sign a year's lease. that gives us a one thing that's fixed, okay, fixed cost. And so then our fixed costs are the cost of capital, our variable costs are the cost of labor. All right. Let's do an example here and see how do things change when we change one variable. Okay, so the example that the book uses is a business which is producing lumber. All right, so the quantity of lumber, okay, we'll call that Q, right? And in this kind of production, we've got we've got labor, okay, and the laborers, the ones who are doing this, they're the lumberjacks, okay. So labor refers to the number of lumberjacks. I know before I said it was hours, but the example that your book uses is just the sheer number of workers. So, by the way, if we do this, we're making a couple of assumptions. Okay, we assume that all workers are equally productive. Okay, this is the assumption that we are using standard units. Okay, every worker is essentially like every other worker, right? They're exactly the same. Adding, we make that assumption implicitly in mathematics, right? Like one is always one in mathematics, right? There aren't different ones, right? You go from 0 to 1 or from 4 to 5 or whatever it is, right? If it's increased by one, it's always one, right? So that's a little bit questionable of an assumption when it comes to people actually working. I mean, I don't know if you've ever worked, you might notice, hey, there's some people get a lot done and others don't get as much done. People are different that way, right? They're different in all kinds of ways, but we're abstracting from that, okay? All units to the production process are identical, okay? So if this is the kind of production that we're doing, we set up a table, okay, and we'll say, all right, let's say we have the number of lumberjacks here, L, and our output here, okay, the amount of lumber. And let's say it looks something like this, okay, we 0, 1, 2, 3, 4, and 5, all right? Imagine that the firm here has done different things. They've said, all right, well, how much are we going to get done? How much lumber are we going to get if we have 0 lumberjacks? Well, the answer is 0, right? What if we have 1? What if we hire 1? Well, we get 4. Okay, all right, now we're getting somewhere. What if we have 10? What if we have 2? Well, we get 10, 10 lumber, right? If we have 3, 12, 4, 13, 5, also 13. Now, why the hell is that? Well, look, what we've assumed here is that the capital is constant, right? So remember what capital is. It's the tools, the equipment, the machinery, all the stuff that goes into production. That's all held constant, right? So because that's held constant, well, adding more units of labor is going to be more helpful, but only up to a certain point, right? I mean, so the number of chainsaws and whatever else that the lumberjacks have is constant, okay? So let's say they have 3 chainsaws. Well, once you get beyond the third one, well, if you can see the fourth one isn't that helpful. What do? Well, they help out when the chainsaw is free or something, right? Like, but there's less that they're going to be able to contribute on the margin. Okay, so because the capital is fixed, the workers can't add as much as the one before. All right, so we can look at this and we can look at what is the change in output. Okay, the delta Q relative to the change in labor. All right, this is a very important concept in microeconomics. Okay, this is known as the marginal physical productivity. Right, the marginal physical productivity of that input, and in this case, it's of labor. Okay, because it's relative. We change labor. Okay, we would also have a marginal physical product of capital if we changed capital. All right, so what's the change in output relative to that change in labor? Okay, so we can say, well, going from 0 to 1, what happened? Well, we went from 0 to 4. Okay, so the marginal physical productivity of labor, okay, the MPP subscript L, all right? Some texts just call it MP, right, marginal product. So, but marginal physical product of labor, okay? We go from 1 to 2, output goes from 4 to 10, so the MPPL there is 6, okay? We go from 2 to 3, output goes from 10 to 12, the change there is 2, then 1, then 0, okay? So we got two things that we can learn from this, okay? The first is what is happening with the total physical product that's Q, okay? So let's graph that, right? Okay, so we're gonna produce two graphs here, okay? The first one is output as a function of labor, okay? So this is the graph, this is the total product curve, okay? That's Q as a function of labor and capital, but we're holding the capital constant, all right? So let's do it this way, 0, 1, 2, 3, 4, and 5, okay, units of labor, and then 3, 6, 9, 12, 15 units of output, all right? We've got a point at 0 and 0. We've got a point at 1 and 4, at 2 and 10, at 3 and 12, 4 and 13, 5 and 13. Okay, so our curve looks like this. All right, and this is the total product curve. Okay, now let's look at the marginal product. Okay, so down here we're going to draw the MPPL. Okay, this one has a different vertical scale, but it has the same horizontal scale. Okay, labor. So I'm lining these up, right? 1, 2, 3, 4, and 5. All right, and looks like we're going to a max of 6 on this side. Okay, 1, 2, 3, 4, 5, and 6. Now this is different, right? This is starting off at 4, okay, right here, going up to 6, right, and then it's going down, okay, to 2, then to 1, and then finally to 0. Okay, so this is our marginal physical product, okay, our MPPL graph. It has a very different shape, okay, because again, I started this discussion talking about the dynamics, right? The red curve here represents the rate of change of this one, right? So see what's happening here, right? This curve gets steeper initially, right? Whenever something gets steeper, its rate of change is like picking up, right? It gets steeper, but then it starts to kind of like level off, and then finally it's totally level, right? When something's totally level, its rate of change is 0, okay? So translating that down here, right, where this becomes flat, the marginal physical product becomes 0, where its slope is increasing, the marginal physical product is increasing, okay? But then when it starts to kind of level off, the marginal physical product goes down, all right? And what this reflects is a general idea in microeconomics, and this is called the law of diminishing marginal productivity. The law of diminishing marginal productivity. Okay, what this means is, look, as you increase any input, okay, as input increases, right, when all other inputs are held constant, all right, held constant. So, like in our example, right, we increase labor holding capital constant, okay? Now, when you do that with any input, what will eventually happen, okay, eventually the marginal physical product of that input will go down. Right? It will diminish, it will decrease. Okay? So the first example of the law of diminishing marginal productivity has to do with crop yield. All right? Crop yield when we add fertilizer. Okay? So because this was obviously a very early topic of interest for production, right? This is the kind of cornerstone of all other forms of production. If we don't produce food, we can't produce anything else, right? Because we're too hungry. We need to eat. And so here we have a situation where everything is carefully controlled, right? We've got the amount of land doesn't change. This is how much land we've got, right? The amount of labor doesn't change. You got one farmer, right? What are you changing? Well, you're adding more fertilizer, okay? And this produces more of a yield. It produces more output, whatever crop you're growing, up to a point, right? So perhaps you add more fertilizer, you get initially you get 30% more yield. Then if you add more fertilizer again, maybe you get another 20%, right? Maybe you get another 10%. Eventually, adding more fertilizer does nothing, right? That's as far as you can go. Okay, so this is where this kind of came from in the history of economic thought, and then it was generalized to include everything, right? So labor, capital, whatever it is, right? But the way that this is established is by looking at the marginal physical product. Okay, so that's part one of my lecture on this topic. Part two is going to pick up right where this one left off. Thank you very much.